Assalamualaikum. In this documentary, we will share about you Science Form 3, Chapter 9, Space Weather.
Test on the Chapter 9 includes 9.1 and 9.2. 9.1 is activities of the Sun that affect Earth. Include structure of the Sun, phenomena that occurs on the surface of the Sun. Phenomena such as granules, sunspot and solar cycle, prominence, solar flares, coronal mass ejection, solar winds. 9.2 Space weather includes space weather and its effects on Earth. Phenomena that occur on the surface of the Sun include 8 phenomena, which is granules, sunspot, solar cycle, prominence, solar flares, coronal mass ejection, and solar winds. Structure of the Sun. As you can see at the diagram on the left, the Sun has 6 layers, which is corona, followed by chromosphere, photosphere, convective zone, radiative zone, and core. The Sun appears as a ball of glowing gases, consists of hydrogen and helium.
Granules. Granules have grainy structures. The upper part of the convection zone of the plasma, which is extremely hot with the temperature of 5800 Celsius.
Sunspot. Sunspot are the region seen on the surface of the Sun as shown to the right. It appears dark because the temperatures are lower than the surrounding areas, which are made up of granules. They are caused by twisting chaotic magnetic field from within the Sun's convective zone, which is the layer of the Sun.
Prominence. A prominence is a huge loop or arc column of glowing gases over the sunspot. It can reach height of hundreds of thousands of kilometers and last for several days or months. Prominence are very strong, can throw out matter from the sun.
Solar flares. As you can see on the video on the right, solar flares are sudden energy bursts from the Sun caused by magnetic disturbance. They can disrupt satellites, communications, power grid, and pose risk to astronauts, often occurring near sunspots.
Moving to the next slide. Coronal mass ejections. A coronal mass ejection is a huge cloud of plasma that erupts from the Sun and often occurs together with solar flares. Coronal mass ejection is an ejection of magnetic gas particles. It spouts magnetic particles at high speeds into outer spaces like expanding cloud. It takes 3 days to Earth.
Solar wind is a continuous flow of charged particles, primarily electrons and protons emitted from the Sun's corona, traveling at speeds between 300 and 800 km per second. When solar wind interacts with Earth's magnetosphere, it can produce aurora. As you can see in this video, this is how the solar wind travels to the Earth's magnetosphere and becomes aurora.
Shapes of Earth's magnetosphere. Earth's magnetosphere is the region around the planet's magnetic field. It is also defined as the region in outer space surrounding Earth. It is also the combination of Earth's magnetic field and the magnetic field in the region in outer space.
Formation of Earth's magnetosphere. Magnetosphere is formed by the interaction between magnetic field brought by the solar wind and Earth's magnetic field. Next, importance of Earth's magnetosphere. The importance of Earth's magnetosphere is to protect Earth from the adverse effects caused by dangerous particles from the Sun or other bodies in the universe. The magnetosphere functions as a biological shield to protect life.
Space weather. It is a phenomenon that occurs on the surface of the Sun, such as solar flares, prominence, sunspots, and coronal mass ejections. In space, such as solar wind, solar radiation storm, and geomagnetic storm.